For the second problem, I chose a question that is slightly tricky for students. You are being challenged to deduce the rate expression for this reaction, so a constant K times reactant 1, which is BF3 power X, reactant 2, which is ammonia raised to power Y. So let's find order of reactions. The first thing we do is find two experiments that concentration of at least one reactant is constant, which is 1 and 2. So I'm going to divide experiment 1 by 2 because I have tendency to divide the bigger number by smaller number. So experiment 1 divided by experiment 2 is rate of experiment 1 is 2.27 times 10 to minus 2 equals a K times concentration of BF3 to power X, which I don't know, times concentration of ammonia to power Y, which I don't know, divided by rate of experiment 2, which is 1.28 times 10 to minus 2 equals K times 1 times 10 to minus 1 raised to power X times 3.75 for concentration of ammonia times 10 minus 2 raised to power Y. What we can cancel at this stage is the rate constant, and also concentrations of A goes away because it's the same number divided by itself, which ends up to be 1. The rates divided by each other will give me 1.77. Concentration of ammonia divided by this is also 1.77 raised to power Y. So we deduce it is first order with respect to ammonia. Now we have to find the order of reaction with respect to BF3. Unfortunately, there is no two concentration for ammonia that are constant. Okay, no big deal. Since we know the order with respect to 1, you can choose any two experiments. I'm going to go after experiment 3 versus 2. So this time I'm dividing 3 by 2 because I see the rate of 3 is slightly bigger than 2. Which is 2.13 times 10 to minus 1 equals a K times concentration of BF3 raised to power X, which I don't know, times concentration of ammonia, which we just figured out, it was 1 raised to power 1, divided by rate of experiment number 2, which is 1.28 times 10 to minus 2 equals a K. Concentration of BF3 for experiment 2 is 1 times 10 to minus 1 raised to power X. Concentration of ammonia is 3.75 times 10 to minus 2 raised to power 1. Let's do our divisions and see what we get. These two numbers divided will give me 16.64. 2.5 times 10 minus 1 divided by 1 times 10 minus 1 is 2.5 raised to power X, multiplied by 2.50 times 10 to minus 1 divided by 3.75 times 10 to minus 2 is 6.67. Now we only have one variable. K's canceled each other out. So I'm going to divide both sides of equality by 6.67. 6.67. 16.64 divided by that gives me 2.50 equals to 2.50 raised to power X. So my last deduction is X is also first order. So we have our rate expression. Rate equals first order with respect to BF3. I don't have to write that exponent, and first order with respect to ammonia. Overall is 1 plus 1, which is second order. Now they say calculate value of K from experiment number 4. So K equals rate of experiment number 4, which is 1.02 times 10 to minus 1, divided by concentrations of BF3 multiplied by ammonia because they are first order. When we do this, I'm calculating 3.4. Now the unit is concentration. 1 minus overall, in this case overall is 2, times second minus 1. So it is 3.4 molarity minus 1 second minus 1. Then again I'm going to expand on molarity, which is mole to power minus 1 dm to power plus 3 second minus 1. My rate constant for this experiment at a given temperature.